Let's get started. Hello, everyone. Welcome to the today's SUMMEER training webinar. My name is Juyong Choi. I'm an assistant professor in Florida at Florida State University. I'm also the director of the NSF-sponsored SUMMEER organization. Today's training webinar is our first SUMMEER webinar, which is titled the EPA's Decision Support Tools for Disaster Risk Management. So as some of you may already know that EPA research team has developed a lot of useful tools for better management of the disaster risk. So today we are going to we invited the two speakers, Paul and Tim from the EPA, to give us some kind of quick demonstration on some of these useful tools. So before we getting started, I would like to remind you that the SUMMEER organizations about the SUMMEER organization. So SUMMEER organization is like the other NSF sponsored EER. It's a newest EER organization which has been supported by NSF in response to the disaster event, but with a focus on the sustainability. And so right now we are starting the memberships for our reconnaissance and trend mission. So if you have not joined our SUMMEER organization, please I include the QR code here. So please you can scan the QR code to redirect it to our SUMMEER membership webpage. Having said that, I would like to introduce today's speaker. We have the two speakers for today's training webinar, Paul Lemieux and the Tim both. So Paul Lemieux is a senior research engineer with the Systems, Tools, and Materials Management branch of the Homeland Security and Materials Management Division of the EPA's Center for Environmental Solutions and Emergency Response. He generally works on the issues related to the cleanup after the chemical, biological, radiological attacks and other kind of the disruptive events such as the disease outbreaks. Paul also has been working on developing the computer-based decision support tools, such as some of the tools that he is going to give the demonstration for. In response to the wide area contamination incidents. We also have another speaker, Timothy Ball, who is the geographer with the Office of the Research and Development at EPA's National Homeland Security Research Center. Tim's work primarily focuses on the response and waste management issues following the such kind of disruptive event. He has also been developing the computer-based decision support tools, in collaboration with the other researchers like the Paul Lemieux, in order to aid the decision makers in responding to the wide area contamination incident. Having said that, I would like to hand it over to our today's presenter. So Paul, please share your screen whenever you're ready.
All right, let's see if I can make this work. You should be able to see my PowerPoint screen. Hang on, it's showing the wrong one.
Yes.
Should be slides filling the screen.
Let's get
All right. Well, Tim and I are going to be presenting a few of the tools we've been working on over the last several years, directed at supporting disaster waste management decision making. And a little bit of background. The Department of Homeland Security has been encouraging communities and large facilities and states to do planning for what they call all hazards, so that when an incident actually does happen, at least there is some, rudimentary planning that's gone on in order to support some of the decision making. And EPA has taken this and expanded it to encourage the same entities, the communities, the states, and large private facilities to look at planning for waste management that might happen if there's a disaster of some kind. And they're trying to promote this all hazards situation so that the most common types of disasters, like a hurricane or a flooding incident or a tornado, we can use the information we get planning for those that would be applicable to other much more infrequent type of disasters, like a biological incident or a radiological incident. So the idea is that by having some of these pre-incident plans in place, it will greatly facilitate the management of the waste, which is a huge problem with some of these large incidents. Some of the things you need to know is, how much waste was generated? What are the characteristics of the waste? If there's a contaminant involved, how are you going to sample and analyze the waste? Who's going to sample it? What might be the waste acceptance criteria to send it off to a landfill, for example? What transportation routes might you use? Because there's going to be a lot of activity involved in the response, so you may not be able to use the most obvious routes to move your waste from point A to point B because you have a bunch of response vehicles going in and out using that road. Or perhaps there's a environmental justice issue with driving the waste through a certain community that's particularly affected by this incident. So being able to plan your transportation routes is really important. And also trying to figure out if you have a contamination incident, what are the trade-offs between your various decisions that you may want to do your decontamination one way, but that affects your waste management. Or you may have constraints on your waste management that might affect how you do the decontamination. So trying to capture this whole system of systems is very important. So the first tool I'm going to show is iWaste, and we're going to send these slides to Professor Choi as soon as they're cleared. We haven't got them signed off on yet, so I can't give them out yet, but it should be in the next couple of days, so I'll be able to send them. But iWaste has just recently got upgraded and put on cloud.gov, so it's out there now. This QR code, you can scan it and it'll bring you to the iWaste website. It has calculators available to estimate the mass and volume of disaster generated waste and debris from a variety of different types of facilities. There's databases of treatment and disposal facilities, such as the location, technical information, if the permits are online, geolocation information. If there's compliance history that's online, that'll be available. There's also kind of a database of guidance documents and other things that we found on the internet that looked like they might be of interest to people. But if you're doing a Google search, some of these things might show up on page 10 and you might never see them. So the idea is we've gathered these things into one place so you can search out, for example, the state of Louisiana's disaster management plan that they used for managing the waste from Hurricane Katrina. That was a very well-developed plan, and so it might be a good example for people to use. We also find information on worker safety and packaging and storage and transportation. We put that all up there as well. So currently the facility databases that iWaste has include landfills, like municipal solid waste landfills, hazardous waste landfills, C&D landfills, combustion facilities like municipal waste combustors, hazardous waste combustors, medical waste combustors, as well as facilities that you might not think would be useful for a response, but they might be, because everything might be on the table and we don't want to just eliminate things out of hand. So like boilers and smelters and other combustion facilities that might be of use. We also have databases of wastewater disposal facilities and other types of facilities like medical waste autoclaves, rendering plants, radioactive waste disposal facilities. So we try to have a good cross section of the types of facilities that might be used. And so with that, I will switch screens. I got to figure out how to do that. So I think I got to stop sharing, and then I got to start sharing again. If I can figure out how to do that. Let's see. I think that's the one. So can you see my web browser?
Yes.
Yes.
Okay, so this is the iWaste tool. It's at iwaste.epa.gov, so it's easy enough URL to remember. Plus, you can have the QR code to access it. And there's three main parts of it. There's the waste materials estimator, there's the database of treatment and disposal facilities, and then kind of the library of guidance and information that we found. So I'll take you real briefly through some of these modules. We try to document where the numbers come from. So if you want, you can change the default parameters if you know something about your situation that mandates, changing some of the numbers. We try to be transparent about where all the numbers came from. Also, there's ways to combine the results from multiple types of facilities in order to get a close approximation to another facility. Like example, an airport terminal. We don't have airport terminals explicitly, but an airport terminal has some similarities to office space and offices and shopping malls. There's elements of that you can combine to get information about a terminal. So for example, you can plug in, say we have an incident that has 1 square mile, but it doesn't have any buildings. So we can generate an estimate, and assuming that there's some contamination, you have soil, you would potentially have 200,000 tons of soil, vegetation, asphalt, and concrete. You can then export this and manipulate the numbers however you see fit. For example, if whatever type of incident you have won't involve contaminated soil, you can delete that. It allows you to download a spreadsheet, and it's in Excel format. Let me see if I can find it here. It's loading Excel slowly. So it gives you essentially different tabs where you can look at the number of structures and change those numbers and scale your waste estimate accordingly as you see fit. Other examples are, let me see here. Let's see. We gotta clear it. So let's get rid of that. And let's say we got 100 single family dwellings that we have to deal with. So it produces a different waste estimate. You can again export these. There's also an application programming interface that you can use in order to access all of this information from your own tools by just doing a simple web call using the JSON format that they use. And it's all documented here, so you can look at how you export the facilities, how you export the waste calculations. And so hopefully people who wanted to essentially plug in their own tools that they're developing, they can access the information out of iWaste and access it that way. In fact, one of our tools that we're working on with our OLEM program office is like a TurboTax type of tool to generate waste management plans. And it essentially accesses these data in order to populate the waste management plans that it makes. So we go back to the home page. You got the treatment and disposal facilities where you can look at different types of facilities. So let's say we want to look at all of the RCRA subtitle C landfills that have the ability to include low-level radioactive waste in their landfill. Let's not do it by state because there's probably not that many of these. Let's try region 2. That might have some. That's New York and New Jersey. EPA's regional offices, there's 10 of them covering the continental United States, Alaska, Hawaii, and the Caribbean. These correspond to FEMA's 10 regions as well. So EPA Region 2 is the same as FEMA's Region 2 as far as their coverage. So no matching facilities. So let's see if we look Region 6, there's probably some. So they have, looks like there's a couple in Texas, and we can look at those, get a list of them. You can export the list to an Excel file again if you want to use that in your planning. You can click if there's a website for that particular facility. You can get information, basic information about it. A lot of times the capacity information for landfills is not readily available. So this one is like most of them. You can look at whether there's a compliance report online. This one does not have one, but you can go to the regulatory offices that are governing the operation of these facilities, and you can get information like from Texas CEQ or Texas TEQ and get information about the different types of permits. So if you're going to send your waste from a disaster to one of these facilities, you can verify that this particular facility has a good compliance record, for example. You can get contact information so you can contact them. The last thing you want to do during a disaster is drive up to the landfill with a truck full of stuff and then have them not take it. You want to make sure that they're willing to take it before it leaves the point of generation. So now we can go back to the home page, and we can go to the guidance and information. So we can look at different types of incidents, like natural disasters. We're going to look at hurricanes, and there's a few examples that we found. Buried in here is the Louisiana planning documents for Hurricane Katrina. In fact, there's an after action report. So anything we try to find on the internet that looks like it's of interest, we try to put it in here so that people don't have to spend a lot of time looking at Google pages of irrelevant hits before they find what they're after. And with that, I will be happy to take some questions now, or if you want to do the questions at the end, I can turn it over to Tim right now.
Okay, thank you, Paul. So right now, we're gonna take maybe some questions from the audience about the tools that Paul just demonstrated. So is there any kind of questions about the iWaste tools and also this kind of disaster related facility? Yes. So Natalie, you can go first.
Thank you, Zhuang. Hello, everybody. This is Nazlı Yeseler. Thank you, Paul, for the valuable information. I have two questions. One relates to the waste estimator that you went over with some examples of an open space area and the building area, 100 resident area. Do those change? Are they a function of disaster type, or is just one estimate essentially for a given type of constraint, meaning a residential building, hospital building, or open space?
The estimates that iWaste gives are just for all disasters, based on these are loosely based on the FEMA's HAZAS infrastructure databases. The thing that the FEMA databases talk about the construction of the buildings, how many square feet are in the buildings, what are the buildings made out of. iWaste adds the contents of the buildings. We worked with places like the Fairfax County School System or Marriott in order to get, what is in a hotel, a typical hotel, what is in a typical hospital, in order to look at what it would take if you had to completely gut the building in order to clean it up. So the idea is you would export those to your Excel file, and then based on your particular situation, you could eliminate some of the waste categories. So like if you aren't going to demolish the buildings and the building structure itself isn't contaminated, you can delete that out of your waste estimate.
Okay, so there's flexibility for us to work on the data. Okay. I had a second question that had to do with the different types of facilities that are listed, and there's many that I personally hadn't thought of, so it's very nice to see a long list of facilities. Do you have, maybe you mentioned this already, listings of recycling facilities, or for instance, concrete, asphalt crushing type of places? Those are potentially part of C&D landfills in some cases, but that may not be the case. Do you have concentrated recycling reuse type of facilities identified?
We don't in iWaste, but one of the tools that our regional office in Chicago, which is Region 5, they've been working on a similar tool. They kind of started it independently from us, and they focused on recycling facilities and those type of facilities. So we're trying to figure out how we can combine these two tools to have a common set of databases that they all use. We haven't done that yet. The last year was spent just getting iWaste onto the cloud.gov, but the plan is to eventually combine all of these tools that have databases of facilities so that we can pick up the slack for the ones that they don't include in theirs and we don't include in ours, so that we'll have a more complete set of facilities. But they've done a good job on the recycling facility, which we had tried to start on it, but realized it would we'd have to pay for databases, and they found another way to get that information other than paying for it.
Okay. Thank you.
Okay, thank you, Paul. We have one more question from the audience. So Jasmine Beckey, please unmute yourself and then ask a question.
Hi, yeah, so I've been working with this post-disaster waste data set that's from specifically flooding. And I've been using iWaste a lot, and it's really such a cool tool. And I've been wondering if it's possible, or if it's been considered to extend iWaste for just specific hazards, or there might be a function where you can actually go change, like for flood generated debris, there might be certain materials, interior materials that might not be, have to be replaced by floods. So I was just wondering if it's either been considered or if there's a way to adjust the interior materials, or I guess just, materials for a specific disaster.
Yes, but it's a yes, but answer. The tool that we've been working on with our OLAM program office to develop the pre-incident waste management plans. That's what lets you do that. They use the API interface of iWaste to pull in all of the particulars of the waste estimate, and then it allows you to pick and choose based on what disaster you're trying to write your plan for. You can pick and choose what of those materials you want to include in your waste estimate. So iWaste doesn't directly do it, but this other tool that is supposed to be, right now, it's kind of on the EPA servers as a quick start version, but the full cloud.gov version is going to be hitting the internet probably in a couple months. They're going through beta testing right now, and that's the one that lets you pick and choose based on your type of disaster that you're planning for. It lets you pick and choose what wastes you want to include and which ones you don't.
Okay, great. That's good to know. Thank you.
Okay, thank you, Jasmine. That's kind of good questions. Is there any questions from the audience before we moving on to the second part of the demonstration? Okay, thank you, Paul. That was really great demonstration. So now let's move on to our second demonstration, which will be given by the team Timothy Bo. Team, please start share your screen whenever you're ready.
All right, let me move some things around here on the screen. Well, hello, everyone. Just making sure that you all can hear me.
Yes.
Okay, good deal. Well, yes, my name is Timothy Bo. As was mentioned, I'm a researcher with EPA's Homeland Security Research Program. I think Paul did a great introduction in terms of why these tools are important as it pertains to trying to understand how you might manage waste, both towards the guidance, but also tools in which one may use to estimate how much waste you have. The next problem we typically have with this type of stuff is, what do you do with it next in terms of how do you get it to that final disposal location? So we have two tools or models that we're going to show today that we've been developing over the past couple of years that first deal with logistics and then deal with the actual staging of waste if that is a option or need for you. So we're going to start with the logistics tool. So assuming that you're probably cutting off the title here, but the title says logistics tool. And this is a GIS-based application that lives in ArcGIS Pro. So in order to use this tool, you do need to have ArcPro installed, license, etc. We are working on transitioning this tool to the web, hopefully in the near future. But as of right now, it's again a requirement to have a GIS ArcPro license and have the application. So it comes as a module that you add in or add on to ArcPro. And how it works is that you step through a number of different tasks, I should say. So you define your task in terms of where the location is. So if you're working off of a plume or an area of interest, you define this within the application. And I'll show an example of this here shortly. We also have a process that we step the user through in terms of having them rank what's important to them, maybe avoiding certain areas when managing or moving waste, but also maybe you want to target specific soil types or land use types, so parking lots, open fields, maybe you want to avoid sensitive areas. You can define these things in the staging tool. So I'm probably going to show the staging tool first, just because it's a little bit easier to show, and then we'll move on to the logistics tool in terms of how we sort of model out the optimal logistics associated with moving around waste. So I'm going to actually switch to my VPN or my virtual machine here. And of course, those of you who are familiar with Murphy's Law, when I came into the office last week, my desktop had died, has perished, unfortunately. So that was where all my models and stuff were stored at. So we're going to be using the virtual machine today. So you may notice a little bit of latency. So what are we looking at here? Well, this is the staging tool. And again, we're looking at ArcPro. I've opened an existing scenario because we don't really have enough time today to go through the entire creation or scenario creation process. So we're going to cheat a little bit. We're going to show snippets of important things that one might be interested in knowing or might find useful. So on the map here in the center, we have some aerial imagery, and we have this very noisy layer also showing. This noisy layer actually depicts areas of most optimal and less optimal staging. Green locations are depicted as most optimal. Orange or red, we don't have a lot of red in this scenario, are depicted as least optimal. And so as a planner, emergency response planner, a decision maker, what have you, this tool is very useful in terms of trying to understand or taking the information from the application Paul just showed. So iWaste, or we have other tools such as the waste estimation support tool, whose sole purpose is to generate estimates as it pertains to the amount of waste an event might generate. Once you have a good estimate, you then might want to identify areas in which you stage that waste, right? Because you're not going to be able to immediately transport all of that waste from the incident location to a disposal site. It's very unlikely. You're likely going to have to identify areas in which you characterize, segregate, or maybe even process to minimize the amount of waste. You'll likely need to identify areas in which this will take place. The really cool thing about this application or this tool is that you can look for specific things that are of interest to you, and based on those things and looking at various different data layers, the tool will identify optimal and least optimal areas. Once you've identified those most optimal areas, in most cases, the tool will then allow you to estimate the surface area, but also the amount of solid and aqueous waste that could be stored in these locations. So let's dive into the tool a little bit. So when you run it, you will have a task, what I'm going to call the task bar on the left side that pops up. And the purpose of the task bar is to really step the user through the number of processes that are necessary to use the tool. We acknowledge that folks aren't ArcGIS experts, right? So you may have someone who just needs to get in here and get an answer, but doesn't have time to learn how to use ArcGIS or ArcPro. So the sequence of tasks that we have set up slowly steps the user through the process in which they use to create or identify these staging areas, in essence, to create this model. And on the right side here is the interface in which they interact with. And again, I'm not going to go through each one of these, but I would say this is one of our more important screens where you're identifying your area of interest. When you first start the tool, you don't necessarily have anything displayed on the screen here. So we can uncheck our heat map. So this is basically what you would see. So this is the Denver area, for those of you who might be familiar with it. But on top of this, I've included a plume. And this plume might tell me an area of interest or contaminated locations in which I'm interested in. So maybe you want to strictly stage waste within that contaminated area. I've also drawn a bounding box here, though, where I'm acknowledging that depending on the type of contamination, the folks who are working to gather or clean up this waste may not be able to stage the waste within the contaminated location. So we may need to look elsewhere outside of that to potentially stage waste and increase our potential capacity. So just as a reminder, this polygon here is my plume, is really only a visual guidance in which I'm using. So you don't actually need to import any data into this tool for it to work. You just need some visual reference, whether that be some imagery or that could be a layer that you load in. Once you've sort of defined any additional layers that you might need to visually reference, you then start going through the processes I pointed out earlier, where you can give your area of interest a name. So the plume that I'm showing on the screen here is affiliated with an exercise we did almost a decade ago. So I would call this my warp, which the name of that scenario was warp. The warp scenario, you can pull in an area of interest. So again, my bounding box here is my area of interest. I drew that using the embedded tool within the window here, but you can also use your plume file or any other layer that you might want to take into consideration. That could be a census tract, a census block, or specific locations in which you want to assess as part of this scenario. We then use a sort of unique approach where an earlier version of this tool, the user would have to go out and retrieve and download all of the various different data sets that the staging tool uses to generate a result. And it's quite a bit of data, right? So we're talking probably about a gig of data on the lower side or lower end of the spectrum in terms of what you have to retrieve to input in this tool. This screen here kind of shows a good example of some of the data sets that we consume to conduct our suitability analysis. So we're looking at elevation, we're looking at land cover types, we're looking at hydrology, we're looking at transportation information and soil types. We use all of this information to conduct that suitability analysis. And here in a little bit, I'll show how you can potentially change as the end user some of the criteria that you might set in terms of what's acceptable and what's not. So just stepping through each of these individually in terms of why they are important. The first one we'll look at is the elevation data set. So obviously you don't necessarily want to put your staging site on the side of a mountain or in a location that's potentially not flat, right? So one of the first things that we included in this assessment is the overall elevation. So the tool is seeking out flat areas, right? But again, if for whatever reason you don't necessarily want a flat location, which I would not advise, you can make those changes later on in terms of the criteria weighting. The next thing we look at is the land cover. And this is kind of important where depending on the type of hazard you're responding to, right? So if it's a contamination incident, or depending on how widespread the event is, or what the policy is for that locality or that state in terms of how they might respond to this type of incident, you can define what surface types or land use types that you want to define as most optimal and least optimal for staging your waste. So for instance, maybe I want to target parking lots. Maybe I want to target parking garages. Maybe I want to avoid urban environments completely and utilize open fields. You can establish that criteria within our weighting data set that references the land cover and land use type data sets. The next thing is trying to identify areas or bodies of water, and this includes lakes, rivers, what have you, that you certainly don't want to stage your waste in, right? You want to avoid that. We also take into consideration that you may want to have some distance between you and that water source, just in case there's, again, if you're working with some type of contaminated waste, such as bio or rad, you definitely don't want any of that leaching into any of your local groundwater or water sources. Next up is our transportation. So we also consume all the road networks that are in your area of interest. So maybe it's important to you to have easy access to a roadway or a roadway network. You can define the distance in which this staging location would be most optimal. Maybe it's a quarter of a mile away from a roadway, or maybe you want to have this as far out in the middle of nowhere as possible, again, to protect or prevent easy access. This is totally up to you. The next thing we look at is the soil type. And this is important for a number of reasons, especially as it pertains to chem, bio, and rad. Mostly for rad, in terms of the different isotopes that we may have to deal with. We may want to target specific soils, such as clay soils, that if you did have an incident where maybe your containment failed and you did have some leakage in terms of contaminated waste getting into the ground, at least you could identify certain soil types that would reduce the migration of a given radionuclide because of a certain soil type. Obviously, sandy soils is something that we want to avoid, where if there was, again, a breakage in your tarp or whatever protective barrier that you have, that you're not making it a lot easier for that contaminant to enter the environment. So that was a mouthful, but we, going back to what we've done here, is that we've actually stood up a site here, what we call the data commons. And the data commons is basically EPA's tool for distributing very large data sets. So we've packaged all of these data into state-specific data sets where you as the user can say, okay, maybe in this instance, I'm working with Colorado, so I can go here and download my Colorado file. This file has all of the data that you need to run this tool. Once you've downloaded that data set rather, you come here where it says the index file. You load in, there's a specific JSON file that's loaded in with the data set. You just reference that file here, and it automatically fills in the data set for you. The data are there in the background. You hit run, everybody's happy. The tool does its thing and will eventually spit out a result. Again, what this does on the end user is it doesn't require you to have to go retrieve all of this information from the various different websites. And it also makes the setup parameters of the model a lot easier to establish. So let's back up in my tasks here. Yes, I'm probably going to regret doing that. But so you first establish an area of interest, which we somewhat did here, where we've talked about the location highlighted on the map is the area of interest that I decided to go with. So I've got that defined. I've loaded in all of my data. You then run what we call the suitability analysis. So I'm going to hit go on that and just show you sort of an example screen of what happens here. So here's where some other magic happens in terms of you've consumed the data. So now you need to define what's important or not important to you. We've made some recommendations. We've also, with this tool, we have a user guide that explains all of this information in detail in terms of if I want to modify what is suitable and not suitable for me, you can do just that. You would just need to go in here and change some of the values for each of the data sets that I've talked about. So again, maybe you want to change the distance from a specific road, or change the distance in which the tool considers when it's trying to locate an area that's close to a roadway. This is where you would do just that. Once you've made these changes, hit run, you then go on to the next step, and you might redefine some of the weights more specifically. But again, the tool steps you through each one of those processes. At the end, the tool will generate a heat map. And there's some kind of interesting things in this scenario that I've created here, where, again, the green areas are most optimal. And recall all of the different things that we're considering here. So we're in my specific scenario, I was avoiding urban areas. I was avoiding areas that were not flat, right? I wanted flat locations to stage my waste. I wanted to avoid bodies of water or any, I think my example was maybe a couple of miles from the nearest body of water. One interesting thing I'm going to point out here is that in this scenario I ran, you can see where Denver is located, assuming you can see my cursor here. Majority of downtown Denver is located in the area that's showing up as red or yellow, which is telling us that this is not very optimal, right? But as you get closer to the rural areas, which again, I changed my criteria to seek out those type of conditions, that you start to see locations that are more suitable. One interesting thing here is that, and we've often talked about these type of locations being potential staging areas, are, well, actually, I'm just going to ask you to guess before I give you the answer, that what are some large areas that are flat, that have concrete or asphalt, that are typically displaced from urban areas, not always, and have easy access to roadway networks. You want to kind of guess yourself, and then I'll kind of remove the image here to show you what that is, because when I do this, it's going to be kind of obvious what based on my criteria was deemed as most optimal. If you guessed an airport or a farm field, you were correct. So this is the Denver International Airport, and you saw even creeping up higher here, we were seeing some better suitability up towards the north, which, thinking about it, airport is flat, a lot of concrete or asphalt to stage things on. This location happens to be in the middle of a farm field, right? So you're starting to see some indications of, maybe this is of interest to me. Maybe I need to capture this. And so what we allow the user to do then is highlight specific locations in which, based on their suitability, they can capture And once they capture that, the tool then allows them to estimate the amount of waste that could be stored there. So once the tool finishes running and you've designated your areas of interest, you can generate the spreadsheet. And what the spreadsheet tells you is that in this example here, I've identified one staging location. I'm looking at RAD, and it gives me my mean suitability score. But the really cool thing here is that it tells me my capacity, both in solid and aqueous waste, that this location would be compatible with, right? And you can select or designate however many locations that you want. So maybe I go selecting multiple locations that might be distance from each other. So I may have staging location 1, staging location 2, etc. And I might want to segregate my waste specific to that location. You can do just that. So you can have multiple staging locations and designate the capacity of those locations as well. And again, this is all based on the criteria that you as the user had established. And it allows you also to specify an area and think through the process of, maybe there's something about this that's not good, right? Or maybe I don't have enough capacity to store the amount of waste that I might be generating or that I know I have. I need to back up and rethink my approach here, which that's the really cool thing about models, right? Is that you can make the mistake in the model and not in the real world. So the end product here is a map, but also a spreadsheet in this instance that you can share with decision makers and think through your different options, or maybe you run the tool based on a different set of criteria. So I'm going to quickly go to our next tool here, just because we're low on time. So Paul talked about specifically estimating waste and the guidance associated with that using his tool. We talked about identifying potential staging locations for storing waste. And now we're going to look at how you get waste from point A to point B and maybe even to point C, hopefully no more than that. So one of the major questions that we're always asked in any type of disaster or any kind of exercise that we're participating in is how much is this going to cost me and how much time is it going to take? And one of the thought processes that we never went through was, we talk about decon and we talk about recovery in terms of, yeah, this is how much waste we would have. Could we dispose it here? Yeah, probably. I think we have the capacity. But what we've lacked is the amount of time and money in which it would take to get the waste from point A to point B, which could be extremely costly or take a good number of years, or potentially even some scenarios we've seen decades to transport that waste, right? So what we did is we developed a model based on ArcPro's embedded networking, road networking capability, which again allows us to seek out most efficient ways in which one may get from point A to point B, but then through some cool math on top of it, where what if I had this much waste of this type, and I knew that I had these type of disposal facilities and these capacities that are nearby, how would I be most efficient in terms of disposing my waste at the nearest facility, fill it up, and then move to the next one? And that process repeats until you either run out of disposal facilities or you run out of waste to dispose of. So we built a tool very similar to the staging tool that I just showed, where again, we use the task system here to step the user through a number of steps where they utilize to define their scenario. This one is very similar also in terms of you don't necessarily need to pull in any extra data for the tool to run. It's nice because this all comes packaged together. It uses the iWaste data set that Paul referenced earlier. But you can bring in reference material like the plume, which is very small because I'm very high up here, but you can see it down there, the wart plume that I referenced earlier. Here, I defined a couple of things. One, my area of interest. So I might have waste staged or stored anywhere within this black box. So maybe for some reason in using my staging tool, have identified staging locations, which tells the tool that, hey, I might have some waste that I need to retrieve from this location. The next step is defining the bounding box in terms of how you tell the tool, this is how far you need to look out for potential disposal locations. Then you define or tell the tool how much waste you have to deal with, and then what are the characteristics of that waste. So in this example, we're using municipal solid waste, but you can also choose for low level, high level, rad waste. We have different options that you can associate the waste with, because obviously the type of waste it is will determine the disposal facilities in which you can dispose of it at. The other cool thing is that we can utilize also the staging facilities that we may have identified through the staging tool and have the logistics tool reference those as well. So maybe you have a ton of staging sites at your disposal and you need to figure out the logistical optimization of getting that waste from your disaster site to those staging sites, or maybe from those staging sites to the disposal facilities. You can do that using this tool. So in this example I have here, you can see that within the orange box here, I told it to look for disposal locations within that box. And the little stars represent MSW sites that I could potentially store my waste at. The greenish lines in the map represent the most optimal way in which I would transport that waste to those locations. And then what the tool does in the background, again, using your series of tasks on the left side here, calculates for you based on the number of trucks or what other vehicles you're using to transport the waste, how many trucks that one may have at their disposal to move the waste, but also, what shifts are they working, how you may need to define the extent of time in which you're willing to operate. So is it several months, years, decades, what have you, to get that job done? The tool will then calculate the cost and time based on the variables that you've established and generate a report for you to take a look at. So let's take a look at one of the example outputs here. So I mentioned that the tool generates cost and time information, right? And the tool goes into great detail in terms of how much it might cost you. We take all kinds of things into consideration, but you as the user can change these variables in the background depending on the type of scenario that you're dealing with. For example, this one takes tolls into consideration. Maybe you're not impacted by tolls. But we established a total cost. So for this scenario, pretty expensive, right? We also look at the number of days in terms of, this one's roughly about a little under a year. I can't remember, trying to remember off the top of my head, and it's in one of these sheets here in terms of how many vehicles we were using. But I think for this scenario, it was number of trucks, 30 trucks and is what I was using to move my specified amount of waste for this scenario. If I'm not happy with this, nearly a year estimate, I may want to change some stuff up, right? I may want to include, maybe I need 60 vehicles, 100 vehicles working nonstop to start transporting the stuff. Again, these are thought processes that you can take into consideration on how you might manage this, the waste or debris that you're dealing with. The tool also makes a list of disposal facilities that were deemed nearest and had the capacity based on the amount of waste that I needed to dispose of. And one other thing I should point out here is, I'm going to scroll to the left. One really cool feature is, and I kind of referenced this earlier, is that once you define how much waste or debris you need to dispose of, it's going to try to dispose of everything that you have based on that area that you defined. If for some reason, let's say that you didn't have enough disposal capacity to dispose of all the waste or debris, it's going to highlight or tell you that, hey, you have this amount of unallocated waste that you either need to stage somewhere else, or maybe even expand the area in which you're looking for whatever disposal capacity that you need. So again, trying to get you the important answers of how much is it going to cost me, how long is it going to take me based on the variables that I've established. But then the important question is based on all of this, have I managed to dispose of everything that I've taken into consideration here? Last and not least, we kind of track all that information that you, the user, has defined, or any of the defaults that we've defined in the back end of the tool. All kinds of fun stuff like loading rates, costs associated with given variables. Again, this is a useful reference that if you're sharing this with decision makers that they can use to reference. So I've talked about, again, a staging tool, logistics tool. Both of these models, I would say, are a little technical, but they really start helping you refine your overall approach, or maybe your plan in terms of how one might respond to an incident, whether it be a natural disaster or a CBR incident, and start getting some realistic numbers that you can begin playing with and evaluating strategies to determine what would be one's most optimal approach, so that when you do decide to act on this, that based on the information that's at least available to you at the time, that you can make or start acting on the most optimal approach. The great thing about these tools is, let's say you get some additional information later on in the response that, oh, I'm going to have a lot more debris than I initially thought. Let's go back in and let's rerun this, and let's make sure that we still have the capacity, or maybe we need to select or evaluate other options. You can do that with this application. So I think that does it for me. I am going to hand it back to Paul, which I believe will close us out. And if we have any time left, I'm happy to answer any questions folks might have. And one more thing, as Paul mentioned, when we distribute the slides, the slides will have QR codes in them that you can scan to get a link to how to download these tools and how to read more about them. So that does it for me.
Okay. Yeah, thank you, team. Actually, since we're almost at the time, but let's take maybe one or two quick questions. And we have one questions from the posted on the chat. Let me read it loudly for you, team. So can you specify the location of recycling and recovery centers instead of landfills? I think that this would be a good addition or expansion of this tool for our application. Maybe integrated the geospatial information from the DDRT tool. Tim, you are muted right now.
Yeah, thank you. That's a good question, and the audio broke up a tad, but I think I know I can answer the question in terms of, you can import custom data sets into the tool. So let's say I had my own list of locations that I wanted to reference for whatever reason. You can import those as well. So we're not married to a single data set in this tool. This example, or when you get the tool, by default, it references the iWaste database, but you can import custom databases. And if I did not answer that question correctly, please let me know or shoot me an email. We can talk about it.
Okay, thank you, team. Let's quickly take one more question. Nazli?
Thank you, Tim. Quick question, two quick questions. One is, for the soil data that you mentioned, the database that's available to identify the soil in a potential temporary storage area, do you know what classification system is used to identify the soil types? You may be muted, perhaps.
I'm doing a really bad job at my unmute thing today. Yeah, I can't off the top of my head remember. We're referencing the USGS data set. Let's see if I can get lucky and quickly find it. In the user guide, we specify all of this information in terms of what data set we're using. I don't think what I'm showing here on the screen is probably going to answer your question, but we did spend a lot of time researching in terms of what would be the appropriate data set to use. I think it's called the Sergo data set, if I remember correctly, and that's split out by different soil groups. And we define, again, targeting specific soil groups based on clay, sandy. Of course, there's all kinds of different soil types, but that information is contained in the user guide, and hopefully that helped answer the question. But yeah, I think it's the Sergo data set by the USGS. Hopefully I'm not getting that wrong.
Okay. And the second quick question, you mentioned inclusion of bodies of water. That's all surface water. Any plans for including depth, the groundwater in the area, or anything along those lines, or not at the moment?
The short answer is not at the moment, but I think it would be something important to consider. So I think it's a great idea. You know, this is one of those things where, you know, after finishing the first iteration of the tool, you think of, oh man, it would have been cool to include that. So we're hoping to open this back up in the next couple of months once we get some more funding to start adding in some additional layers that one might want to consider. But that one is a great one and might be something we look into.
Thank you.
And just to add to what Tim said, USDA has access to, I think them and USGS together made a data set covering the entire US of where the groundwater is too high to allow for burial of animal carcasses. So that may be something we could adapt for this particular tool, because that data set does exist, and we might be able to figure out how to easily incorporate that at some point.
Okay. I think that will conclude our today's training webinar. Thank you so much, the team and the Paul, for the great training webinar. And also, I would like to say thank you for the thank you everyone who attended this training webinar as well. So as I mentioned in the